In this video, we're going to go over the answers for the KutaSoftware Infinite Calculus free worksheet, Derivatives of Inverse Functions. I'll leave a link in the description below so you know how to access this free worksheet and so you know how to support my channel by becoming a patron. So click that Patreon link to find out more. Our instructions for our first section say, for each problem, find the inverse function derivative of x by direct computation. So we're first going to calculate the inverse function, and then we're going to find the derivative of that inverse function. So remembering how to find the inverse, remember y and x will get switched. So we'll have x equal to negative 3y plus 3. So I'll subtract 3 from both sides to get x minus 3 equal to negative 3y, and then I'll divide by negative 3 to get negative x minus 3 over 3 equal to y. But remember, this y is my inverse function, so now I'm going to write this in inverse notation. So the inverse function of x equals negative x over 3, so negative 1/3 x, minus a negative, so plus 3 over 3, which equals 1. So here we have the inverse function of f of x, which is negative 1/3 x plus 1. Now we're going to take the derivative of that. So the derivative of the inverse function of x equals the derivative with respect to x of negative 1/3 x plus 1. The derivative of a constant is 0, so we're looking at the derivative of negative 1/3 x, which is negative 1/3. So the derivative of our inverse function of x equals negative 1/3. Let's move on to number 2. In number 2, again, we're going to first start for direct computation by calculating the inverse function. So if y equals f of x, we're going to switch y and x. So we'll have x equal to negative 2y plus 3. Then I'll subtract 3 from both sides to get that x minus 3 equals negative 2y. Next, I'll divide both sides by a negative 2 to get negative x minus 3 over 2 equals y. So in inverse notation, that's the inverse function of x equals negative x over 2, so negative 1/2 x, minus a negative, so plus 3 over 2. And when I find the derivative of our inverse function of x, that's the derivative of negative 1/2 x plus 3/2, and we can see that 3/2 is a constant, so the derivative of a constant is 0, so I'll have 0 plus the derivative of negative 1/2 x, which is a negative 1/2. So negative 1/2 is the derivative of our inverse function of x in number 2. Now, let's move on to number 3. For problems 3 through 6, we're now going to be finding the derivative of the inverse function of x, f inverse prime of x, by using the theorem. The theorem states that the derivative of the inverse function of x equals 1 all over the derivative of f of the inverse function of x. So what we're going to need to do is we're going to need to calculate the derivative of f and then plug our inverse function in to that derivative, and that's all below our value of 1. Looking at number 3, we have f of x equals negative 5x plus 1. So the derivative of f of x equals a negative 5, because this 1 is a constant of 0 and the derivative of negative 5x is negative 5. So again, the derivative of f of x equals negative 5. Now I'm going to calculate my inverse function of x. The inverse function of x, remember if I switch y and x, I'll solve for that. So I'll have x equal to negative 5y plus 1. I'll subtract 1 from both sides to get x minus 1 equal to negative 5y, and then I'll divide by a negative 5 on both sides to give me that my inverse function of x equals negative x minus 1 over 5. So now that I have my inverse function of x, I'm going to take that value and plug it in for my x in my derivative. However, there is no x within my derivative formula, so regardless of what I plug in, the derivative of f of x is always going to be -5. So the derivative of my inverse of x equals 1 over f prime of -x minus 1 over 5. However, we know that that derivative is always -5. So this is going to equal -1 over 5. 1 over -5 is the same as -1 over 5. And that's my solution in number 3. Now continuing on to number 4, again calculating that inverse function, we have the inverse function of x, and if we switch y and x, that'll be x equal to -2y plus 2, so I'll subtract 2 from both sides to get x minus 2 equals -2y, and then dividing by -2 will give me negative x minus 2 over 2. That's equal to y, or our inverse function of x. Now for the derivative of f of x, or y prime, the derivative is equal to a -2, because the derivative of a constant is 0 and the derivative of -2x is -2. Now note, again, I do not have a variable, so I cannot plug -x minus 2 in for any x value. Therefore, the derivative of my inverse function of x is equal to 1 over -2, or -1 over 2. So if we would have taken the derivative first, we would have seen that it's a constant, therefore we cannot plug in our inverse function. So it would just have been -1 over 2 from the start. Now let's look at number 5. In number 5, f of x, this is the square root of -2x minus 3, which we can write as -2x minus 3 to the 1/2. So when we take the derivative of this, using our chain rule, we're going to take the derivative of our outside function and then the derivative of our inner function. So we'll have 1/2 of -2x minus 3 to the 1/2 minus 1, which is -1/2, and that will get multiplied by the derivative of our inner function, which is -2. So the derivative of f of x equals, note, -2 times 1/2 will be -1, so we'll have the opposite, or negative, of 1 all over -2x minus 3 to the positive 1/2, because we can write this exponent as positive if we put that term in the denominator. So now that we've calculated the derivative of f of x, let's calculate the inverse function of f of x. So switching x and y, we'll get that x equals the square root of -2y minus 3. So what we'll do is we'll simply square both sides to get that x squared equals -2y minus 3, because this squared will cancel out with the square root. Now we'll add 3 to both sides. Doing so will give us x squared plus 3 equal to a -2y. And then lastly, we'll divide by -2. Doing so will give us negative x squared plus 3 over positive 2, which I'll write as -x squared minus 3 all over 2, distributing that negative to each of my terms, the x squared and the 3, and that is equal to our inverse function of x. So you can see now we have our inverse function of f of x, and we have the derivative of f of x. So what I'm going to do is plug all of that into our theorem. And our theorem says that the derivative of the inverse function f of x equals 1 all over the derivative of f of my inverse function of x. So I'm taking the value of my inverse function of x and plugging it in for x in my derivative formula. So this is negative 1 all over negative 2 times x, which x is negative x squared minus 3 all over 2. So here you can see my inverse function f of x, and then that will get subtracted by 3, and that entire quantity is raised to the 1/2. Now, in order to make this a little bit easier to read, remember if we have 1 over a fraction, or 1 divided by a fraction, that's 1 times the reciprocal. So I'm going to write 1 times the reciprocal of this, which is equal to the reciprocal. So we have negative 2 times negative x squared minus 3 over 2 minus 3 to the 1/2. And simplifying, you'll see that my 2 and 2 will cancel out, so I'll have negative, or the opposite of negative x squared, so negative times the opposite of negative x squared, which is a positive x squared, and then a negative times negative 3 will be plus 3, and then I'm subtracting 3 from that, and that's all raised to the 1/2. So 3 and 3 cancel out, so I'll have negative x squared to the 1/2, which x squared to the 1/2 is x, so negative x is my solution for my derivative of my inverse function of x in number 5. And again, that was using our theorem, 1 all over the derivative of f of the inverse function of x. So we found that inverse function of x, we found the derivative of f, and we plug the inverse function of x, that value, in for x in our derivative formula, and that is the value that 1 was divided by in order to give us the derivative of our inverse function. Now let's move on to number 6. In number 6, let's first find the derivative of f of x equals, well, this 4 is a constant, so the derivative of 4 is 0, and 0 plus the derivative of negative 4x cubed, taking the 3 and multiplying it by 4, that will be negative 12 times x to the 3 minus 1, or x squared. So that's the derivative of f of x. Now, time to figure out that inverse, and we're going to plug that inverse in for the x value, and that's all underneath 1. 1 is over that value. So flipping y and x, we'll get x equal to negative 4y cubed minus 4. So we'll add 4 to both sides to get x plus 4 equal to negative 4y cubed. Next, I'll divide by negative 4, and dividing by negative 4 will give me negative x plus 4 all over a positive 4. And that is equal to y cubed. I'm going to quickly rewrite negative x plus 4 over 4, distributing that negative to both x and 4. So I'll have negative x minus 4 all over 4, and I'm also going to take the cube root of both sides, because taking the cube root of both sides will cancel out that exponent of 3, so I'll get the cube root of negative x minus 4 over 4 equal to y, which is my inverse function of x. So now that I have my inverse function of x, I'll plug that in for x in my derivative. So the derivative of my inverse function of x equals negative 12 times the cube root, which I'm going to write as negative x minus 4 over 4, that value to the 1/3, because that's equivalent to the cube root, and then that inverse function is also squared. So this will equal negative 12 times negative x minus 4 over 4 raised to a power of 1/3 times 2, which is 2/3. But remember, for our theorem formula, the derivative of our inverse function of x equals 1 all over the derivative of f of our inverse function of x. So we're going to have 1 over negative 12, so that's going to be negative 1 over a positive 12 times negative x minus 4 all over 4 raised to the 2/3. So again, that's negative 1 over 12 times negative x minus 4 over 4 to the 2/3. That's my derivative in number 6 using the theorem. Now for our last two problems, we're going to find the derivative of the inverse function of x by using the formula, the derivative of y with respect to x equals 1 over the derivative of x with respect to y, where y equals that inverse function of x. So finding the derivative of y with respect to x if y. So what this formula is basically saying, it's saying that the derivative of our inverse is equal to 1 over the derivative of our original function. So if we're finding the derivative of y with respect to x, where y is that inverse function, that's going to equal 1 over the derivative of x with respect to y. So let's flip our x and y values, because solving for y in that case will give us the inverse function of x. So we'll have x equal to y to the 7th plus y minus 3. So now we're going to find the derivative of x with respect to y. So the derivative of x with respect to y equals the derivative of y to the 7th is 7y to the 6th, and the derivative of 1 times y is 1. So now we've solved for the derivative of x with respect to y, and if y is equal to the inverse function of x, the derivative of that inverse function of x is 1 over dx dy. So the derivative of the inverse function of x equals 1 over dx dy, which is 1 over 7y to the 6th plus 1. So again, in number 8, if y is equal to the inverse function of x, in order to solve for the inverse function, we usually start by substituting y in for f of x and then switching. So when we switch, we're setting y equal to the inverse. So we'll have x equal to 3y to the 5th plus 2y plus 5. Again, that's us setting y as the inverse function of x. And usually from here, we solve for that y to get our function in inverse notation. However, because we're using this formula, we're just going to find the derivative of x now with respect to y. So the derivative of x with respect to y, well, if we're taking the derivative of x with respect to y, essentially we're taking the derivative with respect to y of both sides. So dx dy, the derivative of x with respect to y, equals the derivative of 3y to the 5th. 5 will get multiplied to 3 to equal 15, and that's times y to the 5 minus 1, or y to the 4th. So in this case, we're differentiating with respect to y, so y is the variable to which we're applying our differentiation rules. So then we're going to add the derivative of 2y, which is plus 2, and the derivative of a constant is 0, and plus 0, we're not changing that value. So the derivative of x with respect to y is 15y to the 4th plus 2. So for the derivative of our inverse function, that's going to be 1 over the derivative of x with respect to y, which is 1 over 15y to the 4th plus 2. And that's our solution in number 8. If you have any questions, please feel free to leave them in the comments below. And before moving on from this worksheet, remember to like, subscribe, and share. All likes and subscriptions are greatly appreciated.